I wanted to make sure I gave you everything in concise, nice little place for your notes. If you wanted any of this, take a screenshot, grab these notes. All of the different parts that we talked about are on here, like where the issues are for each of these, which hopefully you see coincide with either the cosine or the sine values. Then we talked about the periods being the same. These actually don't have x-intercepts, so that's a key. And then there's no amplitude because of the min and max values not being there. So hopefully you are feeling pretty good about this last section of graphing here before we move on to the shifting and translations that they can throw at us with these new cosecant and secant functions. So here's our third example that you can see is asking us to graph secant, which you need to know, reading it right to left, is the reciprocal of cosine. So right off the bat, I know I'm dealing with cosine, but there are a couple of things that we have to deal with, an A and a B, which we know is going to change our amplitude, even though there technically isn't any. We're going to say it's 3, meaning it's going to have a vertical stretch. And then our period, which is always 2 pi, is now going to be, remember, since it's being done to the angle, the x, we're going to undo that multiplication by 2 by dividing by 2. So our new period is going to be pi, which is therefore going to affect our quarters. When we go to draw this, we will then make all of our tick marks. And again, as long as you have it labeled correctly, I don't care that you actually draw it to scale. Okay? The eye is in the beholder, they say. So I will put 1, 2, 3 for my y's in both directions. And then I will do my quarters by pi over 4. So 1 pi over 4, 2 pi over 4s would simplify to be pi over 2, 3 pi over 4s, and then one more of pi, which we said was our period length. So if you want to do one to the left here, you could do the same, and then go ahead and start graphing. Okay? Because it is a cosine, I will start at my 1, which remember was multiplied by 3 because it's being done to the y. Okay? So then 3, 0, -3, 0, and 3. I will start by graphing my cosine, which I've done in blue. And then from there, I will take and do the actual graph of secant, which we know is just the reciprocal of all these values. We already took care of the amplitude change and the period and quarter change. It's going to be half as big as it normally would be. But remember, we are going to have some issues at the zeros. And those issues, when we do the reciprocal, mean that we have vertical asymptotes. Okay? If you wanted to keep doing those, you'd have another one there. So in that case, that means we would have a final answer when we go to graph this of 3, and the -3 would stay, and then I do the flipped version of this, and that would be my graph. Now again, I don't care if you erase all of this, that's totally up to you, okay? But you need to know that that is the actual graph. So what a lot of people will do when they go to graph the original function, whether it's cosine or sine, they will just lightly draw it so that they remember that this is not part of my actual graph. It's actually what I'm going to use to find it. Okay? So feel free to dash that on there so that you can quickly draw these, but it's that simple. All right, so let's try another one. And on this one, I'm going to go ahead and ask you to pause it and give it a shot on your own. If you already did that with example 3, you're feeling comfortable, you want to just jump right into the homework, go for it. But I'm going to do a few more just to make sure that you guys got it and put some other types of translations on it. Okay, So the first thing I'm looking at here is cosecant. And the cosecant I know is the reciprocal of sine. I also have some a and this time a d that is being done to my x. So when I go to draw these in, I know instead of going up all the way to 1, I'm going to go to 1/2. All the way down to -1, I'll go to -1/2. So that's my amplitude change. And then this is going to be a shift of left pi/4. Okay, but that means I'm going to have my original 1 pi/2, 2 pi/2, 3 pi/2, and 4 pi/2 in both directions. So I'm going to have to take all those values, the 5 key points we call them, 0, pi/2, pi, 3 pi/2, and 2 pi, and I'm going to have to put a subtle shift on each one of those of, like we said, x. We do the opposite, left pi/4. And again, if you were asked to find all 5 key points, then this is what you would have to do. Go through, get your common denominators, add or subtract, and you're done. You have all of the exact values of all of those 5 key points, no different than what we would have drawn with the original sine function. Okay, so I want to do that for you real quick. If you don't want to find all 5 points and you want to just find the beginning and the end, that's okay too. I'd rather have all 5 so your graph is a little bit more precise. But if you only wanted to find this one and that one and then draw it in, you could do that as well. So subtracting that pi/4 to those 5 key points, you get, and now that I've labeled those 5 key points, remembering that, you know what, I was starting with my sine function because we're dealing with cosecant, which is its reciprocal. I started at 0. Now remember, I shifted back pi/4. So this is going to be my 0, my starting point. Then I would go to, instead of 1, remember it's 1/2, at the next, and the next, and the next, and I just labeled them still spaced out, even though it's not going to be drawn to scale, per se. 0, -1/2, and back to 0. So get a little something like that. And remember what we're going to then do at those specific values is wherever there was a 0, we will draw that vertical dashed line we call an asymptote. All the 1s and -1s, which remember we were multiplied by 1/2 to change the amplitude, will stay the same, but the flipped version of these things would give me my final answer. So just for me, it's easy to erase that whole thing. There's your final answer for that 1/2 cosecant of x plus pi/4 is my angle. Okay, hopefully you got that when you tried it on your own. If not, keep working. I'll do another example with you just to make sure. Now here's our 5th and final example, which I'm going to actually give you the graphs this time and have you tell me the equations. So working backwards. Okay, so be careful with these, but right off the bat, it's not easy to see which one is going to be your sine or cosecant curve and which one's going to be your cosine or secant curve. The easiest way to look at these is by changing the asymptotes, right? The asymptotes of each of these is going to be different. And remember, we're looking for the zeros for the asymptotes. So the first one, we were going to look at, all right, where are my asymptotes at? And you can see they're at pi/4 and -pi/4. And that's not usually where they're at. They're usually at the pi/2 increments. So something's definitely changed there. Okay, is this a secant or a cosecant curve? Well, it looks like it's actually starting at what value? 1 for x of 0. So right off the bat, I'm thinking that this has to be a secant. Now, is there something in front? Is there anything else being done to that angle x? Whether it's being multiplied by something, added or subtracted, is there a shift? Those are the types of things that we're going to have to figure out. Remember, that's what we called the A, B, C was on the outside, and then the D. Okay, none of that has changed just because we're now dealing with this new thing called secant. Okay, still going to be looking for those. They're still going to affect all of these the same exact way. If it's being done to the x, it's going to affect the x. All right, and on this first one, you can see there's definitely some changing going on. So we do know that it appears to be a secant graph, and we have to figure out how is it being changed? What is being changed? Does it appear that our amplitude is being changed? There are some changes along the x-axis. Does not look like anything else has been done to the y. It looks like our x-axis is still what our amplitude would be for these things, for our high and low points. So nothing there. It's just a 1, no change. Doesn't look like there's any shifting because our x-axis is still located as the amplitude. So no shifting there either. Plus 0. So we don't usually put those things because they don't do anything. So the only thing that we do have to look at is there any shifts left and right. Well, again, it doesn't appear that there's any shifting left or right, but it does seem like our x-axis has changed from our normal pi over 2 as our first tick mark. Now they have pi over 4. So that means our period has changed. And remember, our period is always 2 pi for these things. Okay? Now, when it's over b, you got to notice that if you can't see it here and how long it's taking, then you have to be able to use this equation and solve for one of the two variables. There's only two. It's either the p or the b. Now, for this one, we said that it looks like the period has changed because our x values have changed. Our quarters have changed. Our quarters appear to be pi over 4. So you could also use that if you wanted to try to find out what that b value is. So in this, we should be able to figure out that, you know what, it looks like here's 1, and then the other would be here, which would be another pi over 4, because this is 1 pi over 4, and this is 2 pi over 4s, or pi over 2. So this one right here, if we did another, it would be 3 pi over 4. And then it would come down that direction. And that would have given us 1 full period, which means if we're 1 pi over 4 there, 2, 3, 4 pi over 4s, then that means we would have a total period of pi. So in order to figure out what would have to be divided by to get that, now it's pretty easy to see that would had to have been a value of 2 in order for those to cancel out and get that pi on the left side that we knew it should be. So our final answer to this would be the secant of what x? Well, we just came up with 2x. And just to kind of talk to you about why it has to be 2x, remember x's are opposite. So instead of it being twice as long in the x, it was half of that, which was pi over 4 for our first tick mark. Okay, so go ahead and pause it, see if you can do part B, and that'll be the last thing that we do before you go on your own and independently try these. All right, hopefully you gave that a try. Right off the bat, I would have drawn this asymptote in there so that I could see that, even though they kind of showed me that it's approaching that value. All right, and you can see that my period of time that would take for this to repeat again would have been a total of 4 pi. So definitely a change from our normal 2 pi like we just discussed over here. So since it starts at 0 for our asymptote, normally what started at 0 was sine. So I'm already thinking that this is going to be a cosecant function. Again, all we have to figure out is what is being done to it. Is it being stretched vertically or shrunk? What about in the x? Or is there anything being subtracted to it as well? Or added? And then how about vertically? Is there a shift? Well, right off the bat, hopefully you can see that it looked like there was our x-axis being shifted up 1, because then this and that still had that amplitude of 1. So we know this should not have changed. We have an idea of it being cosecant since the 0 was our asymptote, just like sine normally was 0. But this seemed to be up 1, our x-axis, which was normally there. So I'm thinking my answer is already cosecant of something plus 1, which, remember, if we don't like it at the end, then what we can often do is, to play it safe, put it in front. So it's not ever thought to be with the angle x. Okay. Now, my quarters period, how are we going to find that? It does not look like we were shifted left or right any, because, again, started at 0, just like this one started at 1. So we knew this was a cosine, and we know this was a sine reciprocal. So the only thing we're still tasked with finding is what is being done to the x by a stretch or a reflection. And so because we have two things to worry about here, normally, remember, it always starts in the positive for sine. It was all students. So right then and there, you should have seen that, you know what? This actually should be a negative 1 times it, not just that. Remember, we called it a reflection. So that was one that a lot of people may have missed. That should be a negative there. Okay, and then from there, we knew that there's also a change for our period. It seems to be twice as long as what we normally would have. And our period is always 2 pi. But to make it twice as long, we'd have to divide by what number? Well, remember, it's actually the opposite for x's. So instead of 2 for twice as long, we saw when it was a 2 there, it would cancel out and be half as long as it normally would be. So in this case, hopefully you can see that it would have had to have been a 1/2 times x. Okay, so just be careful with this part right here. That was the one tricky part, because it did go negative first and then positive, with that shift of being up 1 for my x-axis and our period being elongated to 4 pi. All right? Hang in there, keep working at these things. They will get easier with practice. Just make sure you pay attention to the overlying theme, that is the A, B, D, and C for every single one of these functions. The only thing that will change other than the A, B, C, and D could also be that reflection that we talked about, but most importantly, the function of each of these, whether it be sine, cosine, tangent, cotangent, or now secant or cosecant. All right? Keep plugging away, guys. Hopefully you're feeling good about this chapter after the end here, because the way that I teach it is so that every one of these feels the same. The only difference is the functions themselves. All right? Take care. Have a good one. Keep fighting the good fight. Alan out.